Hey y'all! Well, we're back for round 2 of testing on this R300. We're going a little more deeper into this one than we have in any in the past, given all the comments on the forums, people saying, what's a 300B supposed to test like? Is this normal? Maybe this is what they're supposed to do, and all that kind of stuff. And so I decided to test it against the DIY 300B amp that I built on my channel about a year ago. And this was built as a budget 300B amp. This is not super high-end iron. This is $135 a piece Edcore output transformers, retail price. It's got a 10 Henry Edcore choke. Ended up having to install a Hammond power transformer because the Edcore one died on me. So gives you a little idea about how budget this amplifier really is. The parts came up to at the time about $1,000, and that's retail buying parts, not wholesale. And that was including, these fancy little tube rings and this $100 bias meter that's in LA now and all that kind of stuff. So anyway, this is not a top shelf 300B. It doesn't have, Hashimoto or Tango transformers or $1,000 a pop or any of that kind of stuff. This is just your, again, basic kind of what I would call is probably as little as you can spend to build a 300B amp. But it still turned out really nice. And added some tube rolling, ended up with these Shuggy 300B-Z tubes, which I'm not sure they're even available anymore. These are some new old stock Sylvanias. But to do this test, I took these 300B tubes and these 6S and 7, which are 6HHC Russian tubes, put them in this amp. So we're using the same tubes that came in this amp in this DIY amp. And then we also put some Harmonics 300B tubes, which are some more budget, readily available tubes. I don't have any gold lions to test, which I believe people are saying are a little better than these Harmonics tubes. And then I put these 300B-Z tubes in my DIY amp to show you what they perform like. Honestly, until I do a little more work on this, I don't want to put my really nice 300B tubes in this amp yet. After the reports I've seen of, people having red plate problems, and given these have this black coating, you would never see it until it destroyed the tubes. So, all that said, the goal of this video is to show you, here is what I consider kind of a bottom tier 300B amp performs like versus what the R300 out of the box and with a simple, upgrade of the 300B tubes performs like. So, hope that it kind of explains what we're doing here, and let's get busy testing this amp. Okay, so here is the square wave out of the DIY 300B amp using the PS Vane tubes. And here is a little bit of ringing on the front edge of the 1K square wave. And honestly, this is something I've learned to want to see. When I've seen amps that are tuned where this just rounds off, the amp sounds just dead and has no life to it. So a tiny bit of ringing here on this front leading edge is a good thing. Okay, this is the R300. And clearly we got something wonky going here on this leading edge with this double dip thing. It does flatten out after that, but obviously at the high frequencies there's something going on that's not good, but we're going to dive into that when we start working on the amp. The one thing we may be seeing here is this DIY amp has zero negative feedback. There's none. And I believe the R300 does have a feedback or a negative feedback loop inside the amp. So here's the square wave off of the DIY 300B amp, and you can see the front edge of the square waves fairly rounded off, pretty good bit. And the trailing edge drops off. But not unusual to see this sort of a 10K square wave. Some folks would say it's not ideal, but for an amp with no negative feedback, I think this looks pretty decent. And this is the 10K square wave out of the R300 that we saw the other day, which clearly has got some wonky stuff going here on this leading edge, which we're going to dive into when we get inside this thing. Again, I wanted to show y'all this because I had several people questioning, well, what does another 300B amp look like, and is that normal? That's normal. That's not normal. So next we did a pull, and this is on the R300, of the THD versus frequency. And you can see it starts off here around 2% and goes down, 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 and then it's down here around 0.5%. Once it gets down to 100 hertz, stays flat across the range, and then about 8K it does this little weird dip-de-doo, which I think that is it's losing power here, and the high frequency rolls off, that it's naturally rolling off the THD as well. And then in the next slide, this is the second order harmonics. And if you look at the difference between this and that, it's quite a bit of second order harmonics, which is a good thing for a tube amp. When we go down to the next slide, we can see there's also pretty good bit of third order harmonics, which is not what we want to see in a tube amp. So again, here is the total, there's the second order, there's the third. So here is the DIY 300B amp. It starts off at 2% and it rolls down, and we've got about 0.8% distortion on the DIY amp, which THD, it's a little bit higher than what the R300 is. Now if we look at the second harmonics, you can see the vast majority of the harmonics that we're getting are second order, and then when we check the third order, they're way down here. So while the total harmonic distortion is higher, the vast majority of it is the second order harmonics, which honestly is why I listen to tube amps. So then the last thing we want to check is, this is the THD plus noise versus frequency, and you can see that the THD plus noise on the DIY amp is very similar to the curve of the plain THD only. So we're not getting a lot of extra noise out of this DIY 300B amp. But then we go to the R300, we've definitely got more noise on top of the THD than we had on the DIY 300B amp. So this is the frequency versus THD for the R300, and this is the THD plus noise for the R300. So the next thing we want to look at is the frequency response curve, and you can see on the DIY one there's a very slight bump here between 20 and 30 hertz, maybe even up to like 40 hertz, but we're talking about 0.2 decibels approximately here. That's going to be inaudible. But you can see down here at 20 hertz, we're again maybe 0.2 decibels below what the flat line here is. And so we've basically got a flat frequency response down to 20 hertz. And then as it comes across here, this line, as you can see, is perfectly flat. And then right here about 8K, it starts rolling down. And again, you've got about 0.2 of a decibel of roll off at 10K. And then when you get at 20K, we're looking at about 1.5 decibels of roll off, and then it falls off a cliff, which is what you want to see. You don't want this going flat across, because that's just inviting high frequency ringing and oscillations that could cause some serious problems for the amp. We want to see it roll off like this, and just, I'm sure if this extended, this would just go down through the floor. And so this is the kind of frequency response we want to see on a tube amp, and those big Edcore transformers are giving us this nice boost on the low end so that this thing's going to have some really nice bass. And here's the R300. And you can see it gets flat here about 60 hertz around in here up to about 7K. That range is pretty flat, that's where a lot of the music is. It does have a little bit more roll off on the bottom end. We're looking at maybe 2 decibels at 20 hertz, maybe 3, probably more like 2. So not a horrible roll off on the bottom end. I've seen them way down here and curving up. And so this is pretty nice frequency response. This doesn't bother me. I think it's still going to have some nice bass. But this obviously is weird. It starts rolling off about 7K. When you get here at 10K, you've rolled off at least 3 decibels. And then by the time you get down here at 15K, which honestly there's not a lot of music up here, and a lot of people's hearing doesn't go past 9 to 10K, especially older folks. And so this stuff you probably are not going to hear, but it's there, and something's making it do this. And what I don't like is that it jumps back up here around 30K and then rolls off. But again, I don't know what's causing this. It's definitely a weird frequency response curve that I've never seen in an amplifier before. So I have a feeling it's got something to do with the implementation of the negative feedback, but until we get into the amp, I don't know what's causing it. So this is the DIY amp running the Harmonics 300B tubes. And the amp put out the most power using these tubes. So we got 6.5 watts right at my 2% distortion mark, which is kind of where I draw the limit. This is likely where the amp starts clipping, because you see it just skyrockets off in distortion from there. But this would be listenable distortion. And especially seeing the other curve that showed that the majority of this THD in this amp is from second order harmonics. I'm not concerned at all about considering 2% being kind of the threshold of where we stop. Again, when you go past 1%, it's just a little over a watt. So it does have a little bit of distortion here between 1 watt and 6 watts. But being that it's second order harmonics doesn't concern me, and I know this amp sounds good. So here's the PS vein tube, and you can see up here it makes a half a watt less power, but it's also got a little bit less distortion down here at the 1 to 2 watt range. So this is probably not going to be a bad sounding tube in this amp. And we'll see later that it's likely that this tube actually does sound better than the Harmonics tube. Okay, so here's our THD plus noise for the DIY amp. And you can see it starts out up here a little over 1%, and it comes down, and it gets down here, around 0.5%, maybe a little less, and then it comes back up. It crosses over 1% just before 1 watt, and then at 2% of THD plus noise, we're making 3.7 watts, and it doesn't really go past 2.5% until it hits this 6.5 watt point. So here's the THD plus noise for the PS vein tube, and again, it starts out a little higher, but then it dips down here low, comes up. It's just crossing the 1% mark at 1 watt. But then it actually makes a little more power here at 2%. It's 4.5 watts. And it stays down here low right to the 6 watt point that it made on just the THD plot. So this tube has a little less noise than the electroharmonic tube does. So going to have to sit down and listen to both the tubes. The other day I was really bashing this PH vein tube, but I think this tube would work pretty decent in this DIY amp. And I'm not seeing anything other than a loss of about 1/2 watt of power on the top end, which really just isn't enough to worry about. And before we move on, I was going to do a couple of screenshots of the tubes that I normally run in my DIY amp. Up till now, we've been using either the tubes that came in the R300 or the 6H8C driver tubes, and then a pair of the Electro-Harmonic 300B tubes. What I normally run in my 300B amp are some tall bottle Sylvania and then some Shuggy 300B-Z, those black coated tubes for the 300Bs. And this is what the THD versus power looks like with that tube. And you can see they're at 6 watts. We have just over 1.5% distortion, and down at 1 to 3 watts is all below 1%. Really clean sounding set of tubes. And then if we look at the THD plus noise, you can see it dips down to 0.5% here in the middle, and then it comes back up, crosses 1% at 2 watts, and it hits 2% at 6 watts, and that's THD plus noise. So this is what I normally listen to this amp set up like. So here's the R300 with the Electro-Harmonic tube, and when you look in this range here between 1 and 3 watts, it's actually got a good bit less distortion than the DIY amp. So if you're listening between 1 and 3 watts, it's going to have less harmonic distortion than my DIY amp, which could be partially why people are giving this thing really nice reviews, is they're using super efficient speakers that they're only using 1 or 2 watts of power out of the amp. As you can see, when it gets past this point, it's angled up more sharply, and it does make 6.75 watts at just over 2% distortion. So it's making a breath more power than the DIY amp made with these Electro-Harmonics tube. And here is the R300 with the PS vein tubes. And again, down here in this 1 to 2 watt range, it's under 1% distortion. But this angle here is a lot steeper with the PS vein tube, and you can see we go past the 2% distortion at 5.5 watts. And so we're making 1.25 less watts with this PS vein tube. So here's where things turn a little ugly. Here is the Electro-Harmonics with the THD plus noise, and you can see at the super low volume levels, which you're not going to be listening to, but the noise goes just off the chart. And when you consider the THD plus noise, it barely goes below 1% at any point in the volume level. Right here it's right at 0.8%, and it goes past 1% at 2 watts, and then we're making 5.5 watts at 2% when you add the measured noise into the equation. So here is the PS vein tube with the THD plus noise, and once again it dips down here, maybe a breath lower right in this area, but then unlike the DIY amp, the PS vein tube hits 2% at a lower wattage level than the electroharmonic tube did, which not sure why that's the case, and I'm not sure why we're seeing so much more noise here. But here is the R300 with the THD plus noise versus, and there's the DIY amp with the THD plus noise. So that's the difference in the two curves. Kind of switch back and forth a couple times so you can see them. So if you're like at this 2 watt range, there's really not a whole lot of difference between the two amps like there was when we were just looking at the THD once you add the noise into the equation. So here's some pulls I did at some different frequency ranges, because some people are asking about that. It's like, what kind of THD does it make at 50 hertz or 5K? So we did pulls on all of those. So here's the DIY amp at 50. Here's the R300 at 50. Once again, here's the DIY amp, and these were all running the PS vein tubes. There's the R300 at 1K. Here's the DIY at 5K. And here's the R300 at 5K. Now it's interesting to me how this slope is almost railroad tracking this input voltage. But then when you look at the R300, it dips down here and then it swoops back up on this end. Now do note the difference in the input voltage. The DIY amp has a much less sensitive input. It's just a little over half of what 2 volts RMS that most sources will put out, but it is a lot higher than what we're seeing with this R300. And like I noted, the R300 does have a very sensitive input. So here we did some sweeps with the 8 ohm loads put into various taps on the back of the R300. And this checks if the output transformers are well matched to the 300B tubes that are in this amp. Because as you change the load, that load is reflected to the plate of the output tubes by the winding ratio of the output transformer. So you can change the impedance of the output transformer by either using the different taps or by changing the load. So here we have it with the 8 ohm load put on the 4 ohm taps. As you can see, we lost power. We got 2% distortion at 3.8 watts, and it just seems to have more distortion across the board. As you can see, here it is with the 8 ohm load on the 8 ohm taps. And once again, when we put it on the 16 ohm taps, it lowers it a little bit down here at the 1 watt point, but it definitely makes it higher here, and we're only making 5 watts on the output now versus 6.75. And these pulls were done with the electroharmonics tubes. So there we go. That's about as thorough a test as I can do on this thing with the equipment that I have, but I think it shows the difference in the two amplifiers. And again, there's something to be said for this amp having low THD right in this area right here, but it also seems to have a lot of measured noise, and I'm not sure where that's coming from or what that is. Also, the DIY amp seems to have higher second order harmonic distortion, and this R300 seems to have more of the third order harmonic distortions than this amp does. So this looks like a good place to me to wrap up this video. Well, I hope this video gives you a better understanding of what like a basic 300B amp performs like versus what this does out of the box, and why I have the concerns that I had. And I don't want people labeling this as, oh, you're just doing negative reviews about China products. Guys, I've done some positive reviews about China products, and I also feel like that my reviews aren't negative or positive. Either the products are negative or positive. I'm just posting the facts, especially in these objective videos, of what the meters and what the measurements show. And for folks that think that, oh, well, you're just all about measurements, I'm not. And several of my DIY amps would get trashed over at ASR if Amir tested them, because they definitely have higher than normal distortion. But if you really dive into what that distortion actually is, I'm fine with there being some distortion if there's good distortion, if you know what I'm talking about. And I think most of y'all do that are listening to tube amps, or you wouldn't be looking at this video. So anyway, I have listened to these two amps. Gonna do that in the next video. I will say that I'm not as impressed as some of these other YouTube influencers have been with the R300. And for now, we'll just leave it at that. That'll be coming in the next video. So, if you're enjoying this content, please subscribe to the channel. Please like the video. Thanks again to you Patreon subscribers. Also want to thank you folks that have donated to my website. That helps me afford these DIY projects. And thank you too to you viewers that have drop shipped amplifiers and shipped me stuff to review for you guys, so that we can really understand what's out there in the marketplace. So until next time, have a nice day.